So I'm going to take a couple of minutes to tell you about a somewhat gruesome compiler hack. Well, it's yeah, you'll see. So, if you've ever written some prelude code or something that's supposed to operate over tuples, you've seen this kind of things. There's an instance for pairs and for triples and for 4 tuples and for 5 tuples, and then you ran out of steam. And so you might argue that anyone using more than, say, a 5 tuple is just insane, so they don't deserve any instances. Unfortunately, I don't get to decide which of our users are sane or insane. So I got tired here on this instance of some class with 52 tuples that was needed. So I said, yeah.
Is that one for each week of the year?
It just happened to be 52. It didn't have anything to do with the weeks. And I'm sure there will be 58 tuples any day soon, except now I don't have to worry anymore. So this is the problem. Tuples don't have any inductive structures, so you can't write just something that generates more and more instances. So any solution to this will have to have some kind of compiler support, because these tuple types are built in and there is an unbounded number of them. So there is no way you can do this with just the existing language features. Something has to be added. You could, instead of tuples, use something like HList, which are just nested tuples. But I mean, we don't want to change the things that's already there. You don't want to change the representation of tuples or anything like that. I just want to change the types a little bit. So, imagine a data type called tuple, indexed with a list of types. So pairs would be a tuple where the list of types has 2 elements. Triples would have 3 elements. And the unit would be a tuple with an empty list, and the poor neglected 1 tuple is, you have to have a package installed to get the 1 tuple. It will actually get its own little name here. You could have a tuple with just one thing. You might think that the 1 tuple is useless, but we use it all the time. Yeah, don't ask me why. You could also think of it this way. Maybe it's a GADT with an infinite number of constructors. And of course, that will need some compiler support. I mean, you could think of it this way. This is not the best way to think of it. I'll get back to that. So yes, something has to be built into the compiler here, clearly, because it has to. An infinite number of constructors is tedious to write out. So once you have this tuple type, you can imagine, with a little more compiler support, a class looking something like this. It has 2 methods, const tuple. It takes some A and a tuple that has some stuff in it already, and it makes a tuple that is 1 element longer. Or unconst, that goes the other way, takes a tuple which has something and some other stuff, and it gives you back a pair. And of course you'll need an infinite number of instances for this. But say GHC already has weird type classes with an infinite number of instances to do arithmetic and things like that. So this is just another one. And the implementation of each of these functions is absolutely trivial. I mean, you know what it's going to be, so these can be constructed on demand. And once you have that, equality, you define it on unit, and then you say, well, equality on a tuple that has 1 thing more, you compare that 1 thing and you compare the rest. I mean, exactly as you expect it to look. Or monoids for arbitrary tuples, it looks the way you expect it to look. For equality, you just need an unconst tuple to take them apart. For the monoid one, you need to take them apart, stick them together with an append, and then build the tuple back up again with const tuple. So this is really the whole idea, and I deleted a whole lot of code that we have in our libraries. It feels so good to delete code. It took maybe 2 days to implement, something like that. That included adding a few things to the optimizer so that you get code that is as good for these as for the regular instances. It requires that you unfold all these const tuple and unconst tuple, but once you do that, it works out fine. Seems to work very well in practice. So the bad thing is, of course, that it requires compiler support. And if you wanted to think of it as a GADT, doesn't quite work. So what if you wanted just a type constructor for comma? That doesn't really have any, you can't write that down. It would be like having a capital lambda A, capital lambda B, tuple AB. So that would mean that you couldn't make any instances for, say, pairs of foldable, which would be a good thing. But generally, it's a bad thing. This is just sort of, this tuple syntax should just be viewed as some alternate syntax for tuples. So that's why it's kind of a gruesome hack. It's completely undisciplined. It's one of a kind. But then, I mean, tuples are, I almost said one of a kind, but they are infinite of a kind.
But it comes with it's sort of less expensive than tuples as they are now for this reason.
If you choose this as your explanation of them, yes. But I mean, all I did was to change the unifier and the matcher to match on this capital tuple thing with regular tuples. And there you go. And some infinite instances generated on demand. Because, I mean, I'm sure Simon has felt the pain of tuples.
No, I would have spent 2 days in here with that.
So I'm happy with any other solution to this. This is, I don't think this is beautiful, but it is something. Yeah.
Do you still have the constructors and info pointers and closures of the tuples as they are before, or do they?
There's no runtime change whatsoever. This is purely on the type level.
There must be some runtime change, because at the moment GHC has exactly 62 info tables.
Well, okay, so GHC, I mean, I didn't do this for GHC, I did for our Haskell compiler. It doesn't have any limits on tuples, so you might have to do even more work. At least you get instances up to 62 and then segfault.
I feel like this is a naive question somehow, but what's wrong with just nested tuples? I mean, so I realize that at runtime that's problematic because a lot of boxes, but I wonder if that could just be optimized as a runtime.
So, so the users of this that needed the 52 tuples, say, I would have to explain to them why when they went from 51 to 52 they would have to switch from a regular tuple to a nested tuple. I mean, that's not what you expect. Why would you all of a sudden want to switch?
No, you wouldn't switch. You'd only have pair. You'd have unit, pair, and that's it. And then
you're suggesting that Haskell should get rid of everything but pairs.
Well, with syntactic sugar, so that you can write Haskell the way you
semantics, bottoms.
You probably have to nest a constructor that is lazy in the first argument and split in the second, and you can nest it.
Yeah. Maybe.
Maybe it doesn't work.
Oh yeah.